Welcome to your Daily Digest, where we break down today's most critical global issues. In today's video, we'll explore an innovative and bold approach to cooling the Earth using diamond dust as part of solar radiation management to combat global warming. Stay tuned. Today, we'll dive into the cutting-edge concept of spraying diamond dust in the atmosphere to reduce global temperatures. This geoengineering method, based on solar radiation management, offers a fascinating glimpse into how we might tackle climate change. Solar radiation management, or SRM, is a form of geoengineering that aims to reduce the Earth's temperature by reflecting sunlight back into space. This is done by scattering reflective particles in the upper atmosphere to reduce the amount of solar heat that reaches the surface. Essentially, SRM seeks to manage solar energy before it even touches the Earth. Several materials have been proposed for SRM. These include sulfur dioxide, calcium carbonate, and sodium chloride, each with unique properties and levels of reflectivity. However, diamonds stand out as a particularly efficient material because of their exceptional ability to reflect sunlight. Each material presents its own risks and benefits, and much more research is needed to determine the best option. This idea isn't as far-fetched as it might seem. SRM is inspired by natural processes, particularly volcanic eruptions. For example, when Mount Pinatubo erupted in 1991, it released large amounts of sulfur dioxide into the atmosphere, which cooled the Earth by 0.5 degrees Celsius for nearly 2 years. This natural event demonstrated how scattering particles in the stratosphere can effectively reflect sunlight and cool the planet. So how would diamond dust work in this context? Once sprayed into the upper layers of the atmosphere, specifically the stratosphere, diamond particles would scatter sunlight, reflecting it back into space before it reaches the Earth's surface. This process would mimic the cooling effect of volcanic eruptions, but on a much larger, more controlled scale. The high reflectivity of diamonds makes them especially effective at bouncing sunlight back into space. To make a meaningful impact, the scale of the operation would need to be vast. Research suggests that to reduce the Earth's temperature by 1.6 degrees Celsius, we would need to spray around 5 million tons of diamond dust into the atmosphere annually. This is a monumental logistical challenge that requires extensive infrastructure and global cooperation. Nonetheless, the potential cooling effect could be significant. So why diamonds? First, diamonds are one of the most reflective materials known to science, making them incredibly efficient for this task. Second, this method offers a potentially rapid solution to cool the Earth while we continue to work on long-term, sustainable approaches to climate change. And finally, this approach does not directly contribute to carbon emissions, offering a temporary cooling effect while larger global efforts to cut emissions continue. However, there are substantial challenges to spraying diamond dust on such a large scale. Technologically, we do not yet have the means to carry out such an ambitious plan. The cost of producing and deploying millions of tons of diamond dust would be enormous. Beyond the technical hurdles, there are environmental risks to consider. Large-scale geoengineering could disrupt weather patterns, affect ecosystems, and impact agriculture. Additionally, this is only a temporary solution. SRM doesn't address the root cause of global warming greenhouse gas emissions. It merely treats the symptom. In conclusion, while the idea of using diamond dust for solar radiation management presents an exciting and innovative way to cool the Earth, it is not without its limitations. The technical, environmental, and ethical concerns must be carefully weighed before considering such a drastic approach. Although it offers a temporary solution, it doesn't solve the underlying problem of carbon emissions. Ultimately, it could serve as a stopgap measure while we work on more sustainable solutions to climate change. Thanks for watching your Daily Digest. If you found this video insightful, don't forget to like, share, and subscribe for more deep dives into critical global issues. Until next time, stay informed.